So today's our topic is ferrous materials. So in engineering applications, a lion shares is served by ferrous materials. Means ferrous materials are those where we have some percentage of iron Fe. Okay. So why there are numbers of materials which are coming under ferrous material, or why lion's share is served by ferrous materials? The reasons are the factors which are behind the maximum percentage of ferrous materials are availability of abundant raw materials in the earth. We have abundant raw material which are ferrous material, which are having iron share. Okay, iron percentage is there. Then they are very much economical to extract, economical extraction from raw material, raw iron, to what type of iron you want. It is economical compared to other types of material. Then ease of forming, you can easily make different types of ferrous materials compared to other type of material. Easily we can make ferrous materials. Then versatile mechanical and physical properties, by changing the iron percentage we can have different types of mechanical and physical properties on different types of ferrous material. Okay. So what are the different types of mechanical properties you want, physical properties if you want, that you can get using different types of ferrous materials by changing the percentage or by changing the composition. Okay, we can have different types of mechanical and physical properties in ferrous material. So these are the factors due to which the lion's share in engineering application is served by ferrous materials. Then drawbacks. 1 minute, please. Drawbacks of ferrous material, as this is very much easily available. Due to these are the factors, there are we told that different types of mechanical and physical properties are available. At the same time, there are many drawbacks, or few drawbacks are also there, because not any types of material are fully fully satisfactory in regarding all the aspect of application. Okay, so there are few drawbacks of ferrous materials, which are like, first one is poor corrosion resistance. Ferrous materials are not very much corrosion resistant. Okay, then they have high density and low specific weight strength. Ferrous materials having high density and low specific strength. Okay. uh, then low thermal and electrical conductivities. Ferrous materials having very much low thermal and electrical conductivity. Okay, ferrous materials are very much low thermal and electrical conductive. So these are the drawbacks due to which we have the, or you can say, we are going for advancement of materials. Few disadvantages are always there, so due to which we have more scope to develop new material, right? To overcome these are the drawbacks. So like we are telling that ferrous materials are having poor corrosion resistance. So to overcome this, to have some material which having high corrosion resistance, we can develop a new material, right? Or same way, if we want high thermal and electrical conductive material, then we can make different non-ferrous materials. Okay, so the one kind of thing drawback is the aim, or you can say it's the reason we are developing new material. Always remember that. One material drawback means we have another opportunity, we have more opportunity to make new material. So ferrous materials can also be classified in different ways, mainly depending on steels and cast irons. Okay, so steels and cast iron, they are categorized based on carbon content. How much carbon content is available on your ferrous materials, based on that steels and cast iron can be categorized. Like in steel, the carbon percentage is up to 2.14%, not more than 2.14% is in steel, whereas in cast iron the carbon percentage is more than 2.14%. So please note it down, so that the next time if people remember that, when suppose in any interview we can you can ask that what is the carbon percentage in steel or in cast iron, how you are going to classify ferrous material. In this way you can if this question came, you can write down that in steel we have 2.14% carbon, and in cast iron we have above more than 2.14% carbon. Okay, so these are the two categories of ferrous material. Yeah. So in ferrous material alloys, now our next topic is ferrous alloys. Okay. So cast irons are called so because they are usually manufactured through casting technique, owing to their brittle nature due to presence of iron carbide. So now we will see different types of ferrous alloys. So before starting with our ferrous alloys, here in your syllabus we have different types of, right, uh, irons: cast iron, white cast iron, and mineral cast iron. So let us see having few types of ferrous materials. Okay. So please student, if any point of time, if you have any question, if you are not able to hear me, or if any doubt in seeing the PPT, or if you have any question, you can ask. So ferrous materials, you know that they have a base material which is iron. In ferrous materials, iron is their base material. So ferrous material, again it can be classified like pig iron, wrought iron, plain carbon steel, alloy steel, and cast iron. Previously we have seen that here we have categorized it in steels and cast iron. In okay, so if you classify it in more deeply, you can find that there are pig iron, wrought iron, plain carbon steel, alloy steel, and cast iron. So one by one we will see quickly. We will check that pig iron. So what we have told you that in cast iron carbon percentage is above 2.14%. Remember, please keep it store in your mind. In cast iron carbon percentage is more than 2.14%, whereas in steel the carbon percentage is up to 2.14%, means always below 2.14%. So in pig iron, their carbon percentage is 3.5 to 4%. 3.5 to 4%. Whereas there are other chemical properties are there, like silicon. Their silicon percentage is 1 to 3%. Manganese 0.1 to 1%, phosphorus 0.2 to 1.5%, sulfur less than 0.5%, and the remaining composition is none other than iron. Okay, so this is very we can say very basic step of iron. from or basic phase of raw iron. Okay. So when we discuss about pig iron, you need to remember their percentage. At least carbon percentage you need to remember, and it would be better if you can remember the other percentage, other properties. Like so, in pig iron we have carbon percentage is 3.5 to 4%. So if you see the pig iron or wrought iron or cast iron, you may see that there are very little changes in carbon percentage. But with the little changes in carbon percentage, their properties change huge. Change in properties of their mechanical properties, physical properties are huge. So pig iron, as I told that this is the very much basic phase. So they uses raw material for the production of wrought iron, steel and cast iron. So pig iron there can only be useful to make wrought iron, different type of steel and cast iron. They are used for those purposes only. They are raw material for the production of wrought iron, steel and cast iron. Now wrought iron. So they are produced from pig iron. How they produce? By puddling process or by Bayer's process. Puddling process or Bayer process. If anybody interested, you can check in details about these processes. Here in wrought iron, we have 0.1 to 0.15 percentage of carbon. So it contains high ductility and it can be easily forged and welded. In wrought iron, their properties like they are highly ductile and you can easily forged, you can easily weld. Welding can be possible very easily for wrought iron. So wrought iron, it is generally used for small pipes, fittings, okay, character sheets, and also used for making chains, bolts, nails, anchors, etc. Because if you can see the chain, bolt means you can easily forge them, you can easily weld them, and they are very much high ductile. So due to all those reasons, this wrought iron is used for this type of application in making small pipes, chains, then bolts, nails, anchors, etc. Next is plain carbon steel. Steel is an alloy of iron plus carbon plus more quantities of silica, manganese, phosphorus, sulfur. Okay, so it is plain carbon steel. It is an alloy of many component like iron plus carbon plus very small quantities of silicon, manganese, phosphorus, sulfur, etc. Okay, so it mainly depends on amount of carbon content. So again, by depending on the carbon content on plain carbon steel, it can again classified in three categories: low carbon steel, medium carbon steel, and high carbon steel. So these different type of steel, due to the percentage of carbon, this depends only the percentage of carbon. So in low carbon steel, you will find carbon percentage is 0.08 to 0.3%, 0.08 to 0.3%, and in medium carbon steel means more percentage of carbon, like 0.3 to 0.6%, 0.3 to 0.6% carbon you will find in. medium carbon steels. Whereas in high carbon steels, the carbon percentage are more than 0.6%. Carbon percentage are more than 0.6%, but below 1.5%. More than 0.6%, but below 1.5%. So these are the percentage of carbon in different type of plain carbon steels. So you need to remember the percentage of carbon. Okay. The question is always come from this type of things, like how much percentage of carbon. Okay. Next. Next is let's us see more deeply about different types of plain carbon steel. So low carbon steel, carbon content as I already told 0.08 to 0.3%, right? 0.08 to 0.3% carbon, and their mechanical properties are they are highly ductile, they have good machinability and weldability, means easily they can be machined, easily they can be welded. Ultimate tensile strength is 4000 to 6000 kg per centimeter square. Their ultimate tensile strength. Their Brinell hardness number is 150. Brinell hardness number is 150. Then next properties is not the low carbon steels are not affected by heat treatment. You can't improve the properties by using heat treatment. So their uses are they are used in making wires, rivets, screws, bolts, nuts, sheets, plates, tubes, rods, and for general workshop related things. So for very small basic application, we use low carbon steel. Then medium carbon steel, their carbon content are 0.3 to 0.6%. 0.3 to 0.6%. So their mechanical properties are can be improved by using heat treatment process. Unlike the plain carbon steel, unlike the low carbon steel, you can improve the mechanical properties of medium carbon steel. Low carbon steel mechanical properties can't be improved using heat treatment process, but you can improve mechanical properties of medium carbon steel using heat treatment process. So their mechanical properties are like they are less ductile and machinability means machine ability. Okay, the machine ability are less compared to mild steel, but they are easily you can forgeable, and easily you can weld. Their ultimate tensile stress is 7500 kg per centimeter square. So if you can see in low carbon steel, ultimate tensile strength is up to 6000 kg per centimeter square. But here in medium carbon steel, it is increased. Ultimate tensile strength increases up to 7500 kg per centimeter square. And their Brinell hardness number also increased. For medium carbon steel, Brinell hardness number is 200. So where we can use this medium carbon steel, we can use in making of different types of nut, bolts, springs, different agricultural tools, dies for large forging. These are the things, these are the way or component which we can make using medium carbon steel. Now, what about high carbon steels? In high carbon steel, the carbon content are zero point 0.6 to 1.5%, near about 1.5%. Okay. less than 1.5%. Mechanical properties are further improved by heat treatment process like medium carbon steel. Their mechanical properties are high strength and hardness, then low ductile and malleable, low malleable. Okay, so these are the different mechanical properties: high strength and hardness, but low ductility and malleability. Okay, then these are the properties for up to 0.8% carbon content. Then ultimate tensile strength, it is also increases with the increase of carbon percentage. Here you may find 9500 to 1100, sorry 11,000 kg per centimeter square ultimate tensile strength you can find for high carbon steel. Their Brinell hardness number is 550. So their application is get improved. Now high carbon steel can be used for making springs, metal cutting tools, press work dies, and different types of punches, different dies for forging, different types of hand files, etc. Because their more carbon percentage means you can see their strength also get increases. So here with these three types of carbon steel as a low carbon steel, medium carbon steel, and high carbon steel, you may find that with the changing of few percentage of carbon, their mechanical physical properties are changing drastically. Okay. Now next is alloy steels. So here when we discuss about different type of steel, we find that their carbon and iron percentage are there, but their properties are not that much good for a higher application. For application in some places where the extreme conditions are there. So to be applicable for in higher condition, higher critical situation, we can say we use different types of metals with iron and carbon and making different types of alloy steels. So other than iron and carbon, other metals are used to attain the better properties. So why we generally use alloying elements to steels? Why we are adding different types of alloying elements in steel? These are the reason, like to increase hardenability, to increase different types of mechanical properties, to increase corrosion and wear resistance. As you can see in the beginning, I have told you that in ferrous materials they are not that much corrosive. Corrosive ability is not sorry. Increased corrosion means they are easily they can get corroded. Okay. So to improve that, to improve their corrosion resistance ability, as well as to improve their wear resistance ability, we add different types of alloying elements to different types of steels. Again, to improve different types of magnetic properties, we use alloying elements to steels. So there are different types of alloying elements are there depending on their properties, depending on their application. So different types of alloying elements, alloying metals, you can say are aluminum, chromium, nickel, silicon, etc., etc., titanium, tungsten, vanadium, many types of alloying elements we can add in steel. Okay. So now, how in your syllabus, if you can see, influence of alloying elements. There one point is there. So purpose of alloying we have discussed. Then different alloying elements we have discussed, and their effect on enhancing different characteristics. We will see that. So aluminium. There are here we have discussed different types of alloying metals. Okay, yeah. So now we will see what different types of alloying elements, what are their application, what are their influence. Okay, we will see in detail about the application of, or you can say influence of alloying elements. First is aluminium, right? So, what is the influence of alloying element, aluminium as an alloying element in steel? Deoxidizer. It restricts grain growth. In small quantities, increase strength, but too much gives embrittlement. 2 to 5% imparts resistance to heat and oxidation. So as you can see, we can add different alloying elements to steel, but we can't adding as per our wish. There are some limitation are there. If you increase more, instead of increasing the mechanical properties, you will find that mechanical properties getting decreases, or whatever the properties is already have, we are losing them if we add more percentage of alloying element. That's why how much percentage of alloying elements you will add in your steel, that is important. So if you add aluminum as alloying elements, it will act as a deoxidizer. It will restrict grain growth. Okay. In a small percentage of aluminum, if you add, it will increase the strength. But if you increase it arbitrarily, if you add too much of aluminum, embrittlement occur. Means it will brittleness get occur. It will be easily break down. Then if you add aluminum 2 to 5%, then it imparts resistance to heat and oxidation. Heat conductive, resistance conductive it will become. Okay. Then B, it will increase your hardening agent, it will act as a hardening agent, and expensive only little amount. Okay, as 0.003% is used, too much creates embrittlement and hot shortness. Okay, so anybody able to tell me what is hot shortness? Anyone, did you heard about this? So what happened in hot shortness? In hot shortness, suppose during welding, okay, you did weld of your alloy steel, and when it cool down, as you know, during welding temperature get increases and it get heated. So when it get cooled down, on the along its grain boundaries, crack formation started. So it is, you can say, one kind of welding defect. What type of defect? Defect, cracking of a material along its grain boundaries. cracking of material along its grain boundaries when the welded area cools and solidifies. These are called as a hot shortness. Okay, understood what is a hot shortness, student? Are you able to understood what is hot shortness? So, please respond. You need to respond. Then only I can understood that you people have think and you have understood this.
Hello,
Abhishek
sir.
Raut.
Can you repeat again?
Abhishek Raut.
Hello, sir.
Okay, I will repeat it again. Hot shortness. What happened in hot shortness? See, this is a type of welding defect. Okay. So what happened in welding? We temperature rises, and during the temperature rises, after welding is done, we need to cool it, right? In room temperature, we generally cooled it, or we do slow cooling or fast cooling, whatever the process, different process. So during welding, after welding has done, after you cooled it or solidified it, then along with the grain boundary, crack is formed. Okay, crack formation has been started along with the grain boundaries during solidification of the weld or during cooling of the weld. So that defect is known as what? Shortness. Okay, that defect is known as hot shortness. So understood now what is hot shortness?
Yes, sir.
Okay, I hope the student also understood this. Then next is embrittlement. We are talking about embrittlement. Too much of influencing element, if you add, your material will get embrittle. Embrittlement is, can anybody guess what is embrittlement? Anyone? By seeing the name, embrittlement. Can you please tell me what you have understood from this embrittlement? Don't worry, just express. It always not necessary that it will be correct. Anyone?
The brittleness of that substance may be decreased.
Yes, correct.
Sir, due to
Abhishek.
lack of ductility, sir.
Yes, both of you are correct. Okay. So embrittlement means uh, in embrittlement, the ductility, that properties of the material, it get reduced, decrease. Embrittlement is a significant decrease of ductility of a material, which makes the material brittle. So we are talking about that our ferrous materials are ductile. So if you add different types of alloying elements in more percentage, remember if you add in a optimized quantity, then it will be okay. It will increase your properties. But if you too much add your alloying element, then uh, the embrittlement means the brittleness will get decrease. Sorry, decrease of ductility, increase of brittleness. Sorry, increase of brittleness and decrease of ductility. Embrittlement is increase of brittleness, decrease of ductility. Again, embrittlement is a significant decrease of ductility of a material which makes the material brittle. Okay, so this is embrittlement. Then another alloying elements. influence is like chromium. It forms hard carbides. Okay, if you add chromium, it will form hard carbides. Means the strength will get increases of this material. It imparts properties like strength, impact strength, wear and corrosion resistance when added in small quantity. But means when you add a small quantity of chromium, your impact strength, wear and corrosion resistance will get increased, but it will decrease your machinability. It will decrease hardening temperature. Okay, if you are not able to balance with the nickel. So see, with the increasing or the adding of alloying elements, some properties may increase. Okay, but it will again cause of your decreasing machinability. Your machine ability means you can't easily machine those materials. So advantage thing is there, at the same time some disadvantage are also there. Next, there are lots of alloying elements. We need to go quickly. Cobalt here, red hardness by retaining high carbides on heating. Then can decarburize during heat treatment. It increases strength, residual magnetism, hardness when added in small quantity. But if you add it high quantity, it will decrease your impact strength. Then copper you can add uh, zero point 0.1 to 0.4%. That is good for your material. If you add copper in that quantity, it will increase resistance to atmospheric corrosion, and it will act as a strengthening agent. It will increase resistance to atmospheric corrosion, and it will act as a strengthening agent. Okay. Then manganese, it is less expensive, used for deoxidation and desulfurization of molten steel. Okay. So manganese you can add as a 0.4 to 1%. It will increase your tensile strength and hardness. If you add in more quantity, it will lower your critical temperature. Okay. And it becomes authentic and possesses toughness with ductility. So you need to read, you need to understood how the different alloying elements influence the steels. So these are the many others. So you have to understood this and not going through all those things. So as I already told that the reason why we are adding those alloying elements, the reasons are their application and properties to change their mechanical and physical properties and to increase or to use that material in different applications. We add different types of alloying elements in different percentage. Okay. To actually all the things we do actually to improve its properties. Okay. Now there are if you talk about steels, then there are different type of special purpose steels are there. Okay. So these are generally formed to satisfy the particular needs. They are generally classified in the following types. So depending on their specific application, you can say, to satisfy different specific needs for some specific application where some specific properties are needed. In those cases, we use different type of special purpose steel, like high speed tool steel, high chromium steel, stainless steel, high nickel steel, and high nickel alloys, authentic steels and alloys, heat resistant steels. Few of the from the name itself you can understand their purpose, their application, like heat resistant steels, high speed tool steels. Okay, you can understood their application. So as I already told that these materials has various uses depending upon the situation. Depending what is the situation, depending on that they have used in different way. The material take the advantage of the composite material. So composite material properties or how they work, they take advantage of that. Okay. So these materials, these special purpose steels, they are having different types of application depending on the situation. So we have discussed different types of steels. So again, some more basic about steel in detail. Like steels are one type of alloy whose major component is iron, with carbon being the primary alloying element, primary alloying material element. Okay. So alloying material elements. What is alloying elements? We have discussed already. Alloying material elements. Those elements or material which increase the strength of different types of irons through their effect on the matrix, like composite material. Here also they form different types of matrix and their effect which increase the strength. Carbon acts as a hardening agent, preventing iron atoms from sliding past one another. So here, as I told that carbon is used as a primary alloying material and it acts as a hardening agent. Carbon atoms occupy interstitial sites of Fe. So what is interstitial sites? That I already discussed in previous classes. In one of the classes where in unit 1, we have discussed about unit 1. That time I discussed. If anybody forgot, please go through the notes in interstitial sites. Okay, what is interstitial space or sites? Go through that and you can understand that carbon atoms occupy those interstitial sites of iron. Then varying the amount of carbon and its distribution in the alloy controls the qualities of the resulting steel. So how much carbon percentage you are adding as well as how you are distributing that carbon in the alloys, that will give you the quality. which quality of that steel you want. Okay. Means varying the amount of carbon in its distribution in the alloy controls the qualities of the resulting steel. So how much carbon you are using and how you are distributing, that two things are important. Okay. So today up to this, and in next to, yes, tomorrow we will see about different types of steel that also we already discussed, and we will maybe we will go little bit